Hi, I'm Matt Jaster, Senior Editor for Gear Technology Magazine, and our guest this afternoon is Mark Michaud, Technical Fellowman from REM Surface Engineering. Thanks for joining us today.
Thank you for having me.
Give us a brief background on REM Surface Engineering.
REM Surface Engineering is 50 plus years old. We started in New England as a basic surface finishing company, selling electroplating products, cleaning compounds, whatnot. In the early 1980s, we developed chemically accelerated vibratory finishing, which is still used today in a number of decorative applications. All your hand tools and your snap-on toolbox went through REM before they nickel chrome plated it. In the early 1990s, we focused on surface engineering and changed our name to Surface Engineering. And by our definition, it's any type of component in which it has a functional characteristic to the surface, not decorative. So we're involved in gears and bearings and camshafts and heart pumps and that type of stuff.
All over the place. How has your organization changed in recent years?
Well, with the focus on surface engineering, we've become more and more involved in power transfer applications such as the automotive industry, power generation industry, aircraft industry, and that has led to a lot of global type customer relationships that are very added value type applications. So if the component is going to get heat treated and have critical geometry because it's going to be carrying some sort of lubricant film, they talk to REM first about what's the final finish.
And what will attendees find most interesting at your booth this year?
Well, we're displaying some additive manufactured parts now that are going through a derivative of the REM superfinishing process. We're seeing a lot more direction towards that type of technology being utilized in loaded, moving, power transmission type of applications. So it's something that we're definitely focused on in a very large future approach.
Okay. Explain how the aerospace and automotive industries were pivotal in some of your company's surface finish innovations.
Well, that's an interesting question. First of all, split automotive into two worlds.
Yeah.
You got the race car people.
Right.
They were first to the table. Race car people are great. They'll try anything twice. So when Superfinish first began to get involved in bearings and gears, it was the race car people, NASCAR and Formula One, who said, we'll give it a try. We may not understand it. We know it looks pretty, but you say it's got a function, we'll try it. And to this day, NASCAR and Formula One is fully utilizing us on their gears, transmissions, axles, and engine components. The automotive world has been a tougher nut to crack because their manufacturing philosophy is one part in, one part out. And our basic original technology was throw a bunch of parts in a mass finishing machine, add this fancy chemistry, and get this great result. So the automotive industry liked the technical performance, liked the possibilities that it represented, but they didn't want to install these, offline processes. So that led us to developing what we call rapid ISF, which is literally an automotive geared process where we take one part, do something to it for 3 or 4 minutes, and it's done. Whereas the original process, you throw the parts in for a couple of hours, take all the parts out. So it's much more whip, tack time, automotive philosophy finishing.
Okay. How about aerospace?
Aerospace is basically the world of EHL.
Okay.
High loads at high speeds or high loads at low speeds. And again, the surface engineering of super finishing is very much desired in that type of operating regime because of the surface durability problems that it generates, and super finishing is the ideal solution for most of those EHL applications. Aerospace is the type of application where they will spend the research dollars testing the technology, developing the next generation of gearbox, and getting everything plus the kitchen sink of new technologies into it.
Okay. How has your recent upgraded facility in Texas better prepared your organization to produce advanced surface finishing technologies?
Well, Texas is our R&D center.
Okay.
We have facilities in the United States and in Europe. So more often than not, a customer will come to REM wanting to solve a problem related to the surface finish or incorporate our technology into their basic design system when they're at the prototype phase. So we've expanded the Texas facility in terms of being able to provide services, particularly first article processing on these new knuckle busters that someone has developed and now they're wondering how do we finish it, or for the companies who know enough about REM and isotropic superfinishing to come to us and say, hey, this is what we want. What can you put into the design equations, the rating calculations, using superfinish that will help us get our end goal?
Okay. What are some technologies or capabilities customers might not be aware REM offers the gear industry?
Well, the additive manufacturing is a new technology, and you know the world is wondering when are additive manufactured gears going to actually be used. Well, guess what? There are isotropic superfinished additive manufacturer gears out there in very advanced, you know, I'll call them government applied applications. And it's just a question of time where before the loading, the manufacturing capability that is needed for a critical gear to be able to be additive manufactured on a high volume production basis. So we're staying very close to and are seeking, you know, development programs related to additive manufactured engineered components.
How will surface finishing evolve in the future, and what is your company focusing on in the coming years?
Well, in all fairness, additive manufacturing is a very good example of where it's going to go. But as far as surface finishing goes, let's be honest, we're the last step in the manufacturing process. So everything has been put into it, all the added value is there, and then they put it on our desk and say, how much is it going to cost to give me your smooth and shiny finish? So more often than not, companies are thinking in terms of how much more can we put on the REM stuff and take away from other manufacturing steps. So, you know, there's net shape forging people here. They would like to be able to take a net shape forged gear, throw it into REM, and have it come out perfect, geometrically correct, no other steps involved. So more and more of the burden of the manufacturing sequence is going to be put on surface finishing, because the final surface finish is definitely what is going to make the gear successful or not in the higher load, you know, power density applications, which is what's going to drive the industry.
Do you have anything else to add on the topics, or?
Just remember that, you know, REM, without actually publicly saying on our website, we are a research organization where we have to sell enough products and services to keep the lights turned on. So we are very much always on the forefront of the new developments, the new applications, and we're the company that the high-end engineering manufacturers will come to when they have an idea, when they have a new something. They want to make it smaller, they want to make it transmitting more power, they want to make it out of some crazy new metal. They come to us, and we're the company that's sort of known to be the ones that come up with the answer to the problem.
Okay. Mark, thank you for your time today.
Thank you.
Appreciate it.
Have a great day.